other stem cell, or bone marrow transplants. I then used this cohort to try and confirm that low affinity pairs between the HLA-BW4 gene and the KIR3DL1 gene would result in the most beneficial outcome for the patients undergoing these transplants, specifically acute myeloid leukemia patients. I also wanted to create a database that will help speed up the donor selection process in HSCTs. Introduction. Natural killer cells are the first line of defense that build back up in the body after transplant, and this is why they are so vital to the success rate of these transplants. They can bind or kill target cells. Target cells can be cancerous cells that are left in the recipient's body after undergoing chemotherapy or other serious radiation treatments. I specifically looked at KIR3DL1 and HLA-BW4 because of their vital role in the transplant process. KIR3DL1 is a gene that's expressed on the natural killer cell, therefore it is coming from the donor, while HLA-BW4 is expressed on the target cells left in the recipient. These two genes bind together and two different types of bonds can occur, high affinity or low affinity. High affinity bonds are when the natural killer cell is bound very tightly with the target cell. This means that it completely inhibits killing. This happens when there is a high 3DL1 group matched with a high HLA group. HLA high groups are identified as isoleucine 80, or a low 3DL1 group matched with a low HLA group, which is identified as threonine 80. For a low affinity match, it means that the natural killer cell and the target cell bind very loosely, and this actually allows selective killing to occur. For a low affinity match to happen, there's a mismatch between the high and low groups. So a low 3DL1 would be matched with an HLA I80, or a 3DL1 high allele group would be matched with an HLA T80. Methodology. In part one of my project, I was making the cohort, which ended up being 426 patients. With the help of others in my lab, I extracted the DNA from all patients and then performed PCR to magnify the DNA and gel electrophoresis to look at my results and identify which donors were 3DL1 positive. I then received the HLA typing from the National Marrow Donor Program, and I also received from them the outcomes of the patients who underwent the transplant. In the second part of my project, I was creating the database. I inputted over 1,500 alleles of HLA-BW4 and 3DL1 into a macro template, and then created a scoring system to score each one based on if they were considered a high, null, low, or an I80 or a T80 group. I then tested the scoring system using the first part of my project, which was the 426 allele-typed cohort. Lastly, I compared the patient outcomes I received from the NMDP to the affinity score that I got in my database. Results and conclusions. Allele identification. I identified which alleles were considered high, low, null, or T80 or I80 based on these prefixes that I got from Fabio Giglio's 2012 paper. This paper was the first paper that acknowledged the difference between a high and low affinity match. I then created a scoring system so that there were no overlaps, and by scoring each allele based on whether it was a high, low, null, I80, or T80, these combinations would then tell us a score that would help identify what type of donors we're looking for. After testing my database with the 426 patients, I calculated hazard ratios and was able to see that the high affinity pairs were 7.3 and 4.7 times more likely to relapse than the low affinity pairs. This data had a p-value of 0.00056 and 0.002 for the other high affinity scenario. This shows that this data is statistically significant and that low affinity pairs are clearly the most beneficial way to match a donor with a recipient for an HSCT. So what was the goal and significance of my project? My first goal was to make donor selection even more specific, which I did by confirming low affinity pairs are the most beneficial matches, specifically for acute myeloid leukemia patients that hadn't been looked at in this study before. Understanding more specific techniques for selecting donors can help us lower death and relapse rates for these patients by ensuring the success of their transplants. My second goal was speeding up the donor selection process, which I did by creating the database of all the 3DL1 and BW4 alleles. Though in the future we will need to add many more genes, allele types to these databases, if we can create a universal database between all different donor banks, then if one doctor inputs the alleles from their patient and gets a certain score, it can go to all different donor banks at once, and it'll be a much faster process, and we'll be looking much more widespread for a donor, which, as many of you know, is very, very hard to come by. I would like to thank Dr. Chu for letting me work in her lab, and Mr. Stephen Baltakis, and that concludes my presentation.